All right, Algebra 1 students, this is your teacher, Mr. Morris, coming on here, and I just want to reinforce the skill set of how to solve equations, quadratic equations by square root. So, in case you're wondering how to spell quadratic, there it is, quadratic equations by square root. This symbol right here, we often call that the square root symbol, or some people, another term would be radical. And so we already talked about how to reduce in radical form. Just as a quick recap, let's say I had the number, let's do a good one. Let's say we had the number 48, and I were to ask you to take the square root of 48. Well, you can get a decimal if you just put that in your calculator as is, or you could reduce it in what's called radical form. And so when you do that, as a recap, remember you want to find the largest perfect square factor that goes into the number that we call here the radicand. And so after giving it some thought, I've concluded that 16 times 3 gives me 48. And so which one of those two numbers is the perfect square? That's right, it is the 16. I can take the square root of 16 easily, tell you it's 4, bring down the square root of 3, leave it under the radical, and that's how you reduce a problem in radical form. So we gave a quick homework assignment, page 508. I think it was 60 through 68, due Tuesday, tomorrow. But I wanted to go over a couple of those and also give you an instance where you might have to reduce it in what's called radical form and show you what that would look like. So we're going to look at some more solving by square root. All right, so this is solving by square root. And forgive me if it kind of looks like chicken scratch, but that's my handwriting. So guys, here we go. So with the homework was 60 through 68, I wanted to take a look at a couple interesting scenarios, if you will. So I'm going to start with this one. This is actually number 68 from the homework. I'm not really going in any particular order, but that was 7x squared minus 63 set equal to 0. You were asked to solve by square root. So just like any equation, you always want to get the variable isolated by itself. I used the analogy in class. I said, hey, it's almost like you had your friend come over. I think you remembered me explaining it this way in class. And, hey, man, you've been cool. It's been 2 hours, but it's time for you to go. I want to be alone and need my me time, right? So who's easier to get rid of, my brother or the friend who just came over for a couple hours? Yeah, that friend needs to go. So how'd you come in? Oh, subtract 63. We have to do the opposite to kick you out, right? So it's kind of my weird way of putting it. So I'm going to do the opposite of what is currently happening operationally. That gets rid of the 63, and then I just kind of bring down what's left. And of course, to get x squared by itself, I got to get rid of this coefficient 7. Right now, currently 7 is being multiplied to the x squared. So in order to undo multiplication, I have to divide both sides. 63 divided by 7, I believe that is 9. Last time I checked. Feel free to check my math on that, but I think I'm right. And of course, we don't want to know what x squared is. We really want to know what x by itself is. So you could think of it as two ways. You could say, okay, well, what number, if I were to raise it to 2, what number squared equals 9? And obviously that would be 3, which is the answer. But if we want to do it algebraically, of course, we undo a power by doing the square root. Okay, so we square root both sides. That undoes the 2. Finally, x is by itself, but here's the kicker. When you take the square root of a number, don't give me your answer and just say it's 3, because that would technically only be half right. Quadratics always have 2 answers, okay? So yes, 3 is correct, but don't forget that also negative 3 is correct, because if you think about it, negative 3 squared also equals 9. Right? Because a negative times a negative is a positive. 3 times 3 is 9, but so is negative 3 times negative 3. It is also 9. So when you give me my answers, I need either 2 separate answers like this, 3 and negative 3, or another acceptable answer is this kind of shorthand. Told you math guys are lazy. So that means plus or minus 3. That means either one is an acceptable representation. Okay? So that just should be a recap or just a clarifier for how you were to perform the homework assignment. I want to show you an example where you actually would have no solution, and that actually occurred on question 64. 5 of the homework. You may have got stuck on that, I don't know, but this will help you either way. This one is also a 7x squared question, but looks like this, okay? So not exactly the same thing. Just like before, you got to get the variable isolated by itself. How do I do that? The easiest thing to do is to get the one not attached to me away first. So if it's a plus 30, I know I have to subtract both sides by 30. Undoes 30 there. 9 minus 30, I believe, is a negative 21. Bring down what's left, right? Now, to get x by itself, time to get rid of 7. It's too close to me, right? 7 times x squared. So if I divide both sides by 7, that leaves me with x squared equals a negative 3. Now watch this. I don't know if I got a chance to give you an example like this in class before spring break, so I really need you to pay attention right now. Nicholas, Ashton, listen carefully, okay? So you got x squared equals negative 3. Just like the last problem where we had to square root both sides of the equation, you need to do the same thing here, but watch something very interesting. You square root an x squared, that becomes x, fine. But looky, can you take the square root of a negative number? Really? I mean, what times what equals negative 3? For that matter, what times whatever equals a negative number? It's actually not possible. So at least you're not going to get any real solutions. We'll talk about something called imaginary solutions when we get there. But for right now, just know, technically speaking, you're not going to get any real answers. Can't do it. Excuse me, I'm fighting off something. So that's why we say no solution when that's the case. All right? Cool. Now, I'm going to go ahead and give you a little snapshot as to what your homework's going to be. And if you give me a second, let me turn the page. Ooh, where is it? Where is it? I dog-eared it. Here we go. It's actually page 529 in your text. It's a bit of a review, but this will give you some examples. Let's see. I thought I was going to give you some examples. Just kidding. We're learning on the fly here. It's just like real class. All right, we're going back to page 508. I saw one. Okay, here it is. Sorry, it wasn't page 529. It's actually on the same page. So if you look right here, this is question 71 I wanted to look at here. As you see, the answer booklet, it's giving you these very specific approximate answers with decimals. But I want us to practice doing these kinds of questions in what's called radical form. So I'm going to copy down question 71. And we should take a look at this. And we're going to see how this skill, reducing in radical form, actually plays out in the real world. Or in a real quadratic equation that you have to solve by square root. So you got 2x squared minus 4 equals 10. Same story, right? You want to add 4. You got 14. Hopefully you're hanging with me so far and it's starting to catch. You got to get rid of the 2, just like before. Get rid of the 2. So now what you have is x squared. 14 divided by 2 is 7. And just like before, you do need to square root both sides. Now, if you were to leave your answer in what I am calling radical form, which you're going to want to get used to seeing, especially when it comes to the ACT test and things like that, know that 7, maybe it can be reduced, or did you know you can just simply leave your answer like the square root of 7? It's absolutely okay, because I can't, well, I would say plus or minus the square root of 7, right? Because I can't really break 7 down anymore. It's a prime number, okay? It's a prime number. So what times what equals 7? Only 1 and 7. Neither one of those are perfect squares, all right? So I can't really do anything else other than leave it under the radical. And did you know if you leave it in radical form, that's perfectly acceptable to do. You still need to ask yourself, are any factors of this radicand perfect squares? But sometimes the answer simply is no, it's not. You can't, okay? So I wanted to just show you an example where that comes into play, all right? So your homework will be listed on my Facebook page and the Morrissey Awards Facebook page like we usually do. But here is your lesson here on the Michael's Homeschool Academy group, okay? So going over just a few of those looks, be on the lookout for the homework assignment, and I will be emailing out your test scores within about 24 hours. Okay, so be on the lookout for your email with that. All right, I hope this is helpful. We need to just get back up on the horse. It's been a couple of weeks, so I'm sure y'all needed to see another example with these solved by square roots, and that's what I wanted to do today, get you back up and ready. All right, God bless. See you guys soon. Stay safe.